Welcome to Rubber Duck Engineering. Tonight we're going to code in Java.
Java?
And we're going to write a hash table.
What now?
I have written a hash table. It was a while ago. Much more recently than I ever wrote in Java.
When I was going through school, Java was like the future.
Oh,
they're like, you have to learn Java. All programming in the future is going to be in Java. And they were half right, I guess. Kind of.
Well, it's interesting that Java, and I think it actually taught me a lesson because Java, what we thought we were going to do with Java is not what we ended up doing with Java.
That's true. It was going to be like Java on the client. It was going to be like applets were the future.
Correct.
And
rings and
I mean, they were right in the sense that like we're not writing in assembly anymore. We're like
correct.
most software that's written is written in a managed language. Java being like the first like mass market managed language.
But it won on the server, not on the client, which I don't know if like Java people expected. But like we had the privilege on Flutter of working with some people who had worked on Swing, back in more of a heyday of Java than currently. Anyways, you were saying.
Oh, William is welcoming you back. Welcome back.
Well, thanks. I can't remember what I was. Oh, I was off at an event last week.
Yeah, we missed the show last week, so
that's true.
Anyway, hash tables.
Hash tables.
Is this like something you go to Vegas and you go play the hash table, and if it goes well, you get to eat the fancy dinner?
Are collisions good or bad in that analogy?
Good? I don't know. Look.
Hash tables, I mean, people think of them as dictionaries or maps. What are they?
They're super common data structure. Like there's like arrays, and like the next step up from array is like hash table.
And they're not that complicated to build. I'm sure the fancy ones that you actually use in your day-to-day will be way fancier than what we'll put together tonight. But pretty simple principles. They have some neat... so we could go...
Java to Kotlin. Yeah, Kotlin, future episode. This episode, old school Java. It made void, public static, no int. That was the C programmer to be sneaking out. But yeah, so the concept of a hash table is you have a key and a value. And so it's an associative array where instead of in a normal array, you have to use integers to index into the array to get the values out. In a hash table, you can use any old key you like. And often in a type language, you have to specify the type of the key. And then a hash table is a particular implementation strategy for this data structure. Another common implementation strategy is a tree. Trees of various kinds.
I have been using this recently with one of the folks I'm mentoring. But hash tables, the reason why you like them is this.
So the search time. So that's if you have the key and you want to get the value.
How long does it take?
Right. So order one means it doesn't matter how many things are in your hash table. It's the same amount of work to go get the value. So maybe you might think if n gets really big, that might be advantageous. If n is small, maybe you want to study more carefully. Hash table versus set. Excellent question. So one way to think of a set is a hash table where the value is true or false, meaning is this key contained in the set?
Yep.
But a hash table more generally can have any kind of value you like.
Yep. Yeah.
Should we try it? Do we go to the code machine?
Let us go to the code machine.
So the trick in the hash table is basically you have some way of translating your object into a hash code, so some numerical value, and then you make an array and you store the value at that location. Except you don't want to have an array that's a bajillion megabytes big. So instead you fold the hash value so that many hash values will arrive at the same cell. And so then you have to have some strategy for saying what happens if two actual keys that are actually in use both arrive at the same cell. That's called a collision, and you got to have some strategy for dealing with that. And different hash tables have different strategies, which I'm sure we'll get into as we get there.
Sorry, I got a little distracted, but I'm back with you. Yes. So the whole magic of the hash table is the fact that you have a hash function, which I think we talked about in a previous episode.
Well, we looked at cryptographic hash functions, so those tend to be overkill for a hash table. Usually use one that's faster. But what's nice about the reason why we selected Java for this episode is because Java has a built-in hash function where every object has a function on it that will give you its hash code.
I'm sorry. I will be right.
Okay. So I think we might just start by sketching out the contract hash function. So there's the operations are insert. So insert takes a key and a value and puts it into the hash table. And there's delete, which removes it. And there's lookup, which returns it. Even Copilot knows this contract. So I think in Java we have to make a whole new file to make a new, like we want to make our hash table class, right? We have to make a whole new file for the class. We can't put it in the same file.
I don't remember. Maybe.
I think so.
So to go back, sorry, I was distracted by local goings-ons, but the magic of a hash table comes from a hash function, which we talked about right before.
Yep.
And the idea of a hash function is that it maps an arbitrary amount of data into a same size key space. Right? So you take any amount of data and you map it into like 128 bits. And so that's the same thing that this exploits. You could imagine that if you have this number and then you had an array, the way that hash tables work is that they just have a set of buckets. It's just an array. And if you take this is your key, and you just then take your key, mod the number of buckets, and you put your data in that bucket.
Yeah, so I think we should try that. We should make that in code.
Yeah.
So William is asking, like, these are strategies for dealing with collisions. So I think we should first get ourselves in trouble, like make a collision happen, and then we'll have to pick a strategy for dealing with the collisions.
Yep. Yeah, exactly. And that's where a lot of the fanciness gets to, is like, how many buckets do you decide you have? You know, what hash function do you use? What is your strategy for dealing with collisions? But
so I created a file called hashtable.java.
I don't see it.
You may need to refresh. You see that circular button at the top, right above where the scrollable area. Yeah, there you go.
Whoa. I wonder how it can get out of sync like that. Okay, go ahead. Is this going to collide with any known Java names? I guess Java namespace is everything, so probably not.
I don't think so. I don't really remember how to do Java.
I don't either.
Here's my dream for a generic class.
Okay.
Write the contract.
Yeah, to be clear, the last time I've never written Java professionally. And the last time I wrote Java, that's not true. I've written probably Android code in Java professionally. But the last time I wrote any serious amount of Java was in the last century. So I think you need more statics and voids here.
Okay.
Right?
Yep. I don't know if this is like proper Java style. I've never written a serious amount of code in Java.
That to be presumably.
The compiler seems there are not that many squiggles, so that seems good.
Methods was return result type B. Okay, sure.
Okay, return null, no problem.
Okay.
Now we need our storage, right? So
I bet these need public. It doesn't have enough words next to the method name in Java.
So we want a V, one of these values. Oh, maybe the square brackets.
Oh, these are your buckets?
These are my buckets.
So that's not actually the signature that you're going to want, but maybe we're going to get to that.
Oh, it's not? What am I going to want?
You're going to want, I don't know what Java does, it like that.
Oh, well, that depends on the collision strategy. I thought we would start naive and just pretend like collisions aren't a thing, and
Okay.
then and then I need to initialize it. Can I initialize it here, or do I need to write a constructor? We're gonna find out. V default capacity. No, that's
No, I
not.
cannot create a generic array of V.
Right. So, okay.
Just look it up.
Oops,
Oh, that's right. We could have written in C#. Java arrays, unlike generics, contain at runtime information about its component type. So you must know the component type when you're.
Okay, so this is the thing about Java generics. So in Java, the type parameters are erased by the compiler. They only exist at like type checking time. They don't exist at runtime. So we just need to make arbitrary objects here.
Okay.
Do a bunch of type coercion.
To be clear,
So,
we're neither Java experts or HashTable experts.
in fact, we have no idea what we're doing.
Where's
our banner? Show the banner. Show the banner.
Yes, continue.
Right, we'll figure it out.
Uh-huh.
Okay, so here we go. We construct it. So maybe this suggests that I could actually construct it here like this. Yes. Okay, it's happy about that.
Value of is not used. Yeah, fine. We haven't done that yet. Uh-huh.
Okay, so here's what Copilot wants me to write. Of course, is mostly correct.
Yep. Yeah.
Okay. All right. So take the key. We get its hash code. We mod it by the length of the bucket. So we.
Well, I wonder if this is Copilot reacting to this. Because it would do that.
You can delete that too. But just to show what this is doing, right? So this is a built-in Java function that any object has that will it's part of Java Lang object, the hash code function.
Mm-hmm.
And this will just give you an integer that's the hash code for the object, which is very convenient. Dart has something similar built into every object. And then here we're taking the mod by the length to basically project it down into the number of buckets that we have.
Yep.
And then we're storing it there. So like to do.
So we don't actually know if this is going to do a good. Well, like we're very dependent on like the evenness of this hash, specifically like its last few bits.
Mm-hmm.
Right. What this is basically doing, this length, is chopping off the first many bits of the hash.
Should we apply some more complicated?
Yeah. So you kind of want to hash directly into your bucket length. Actually, this is just from the hip. I don't actually know if it's a good idea, but that would make sense to me.
I think you're completely correct. I think just to build up in terms of complexity, we'll start with this.
Yep.
And here I factored it out into a function because we're going to have to do it a bunch of places. But we'll want to do something more complicated there. So then delete. Delete is pretty simple, right? We do the same thing where we get the index, and then we set the value to null. We want to like throw an exception if the value isn't there.
Sure. We're going to tell it throws. Yeah.
Throws exception.
What happens if you don't? Does it not allow you to throw?
Yeah, the type checker will check all of your exceptions. Whoa. And it get mad at you. So throws it like we're really supposed to declare our exceptions. Like
what kinds we have.
Yeah. Well, no, we're supposed to like declare like HashTable exception, insert blah blah blah. Like
okay.
We're gonna say if
Yeah, like I wonder what parts of Java actually came to matter.
William makes a good point. There are checked and unchecked exceptions. So there's like the first division in the exception type hierarchy is like, do you have to declare this exception? So like null pointer exceptions, you don't have to declare. because basically everything can throw a null pointer exception. It's sort of the opposite of these more modern approaches where you have to declare nullability. Here in Java, they just assume everything is going to throw a null pointer exception. And so that's by far, in a way, the most common way your Java program fails is that Java programs basically don't crash, right? But instead they throw a null pointer exception, so they throw like array out of bounds exceptions. Checked exceptions are effect types. Yes, this is true.
I was sitting here musing about like, what is it that made Java successful? Was it the platform independence that allowed you to run on either a Windows server or a Linux server? Because like Java came around when like Linux was taking over the world really early on. Like, was it that it was, a major garbage collected language which allowed you to like writing in a non-garbage collected language is really hard. At least it used to be.
Well, I think just Java is just I think the alternative at the time was C++. And Java is just like massively easier to program than C++. Just because because of the garbage collection is one thing, and also just there's no like header file implementation separation. You don't have to write this weird if-def thing at the top of all of your headers, and like writing C++ is just hard. Like it's just, and there weren't a ton of other competitors at this that were marketed at this scale.
Okay, so
we should do lookup, right? So lookup's going to be sort of similar, except it's like the opposite of delete, right? If it's if it is null, throw not found. Otherwise, we return it.
Okay.
We got to cast this to a v.
So this will silently overwrite on
silently overwrite.
Right here.
Yeah.
We will just silently overwrite on collisions. Which is fine.
Okay. Well,
we just write a program that shows that.
Yep.
Unchecked cast from object to v.
Okay, we need to learn how to do casting.
Can we not just can we not just do this in the constructor and have it work?
No, because you can't. There's no way of actually instantiating a v because its type is erased.
Oh.
Yeah, and so you have to.
Is this like an as v thing?
I'm not sure what the syntax is. Java type casting checked.
Fast?
Cast.
Whoa. Unchecked cast. I don't know how you check a cast. Type cast. Java. No, not JavaScript. Java.
Okay.
This is not what I want. Did you solve it?
No. I'm
Why did
someone to teach me Java?
Oh, I can try that. Why don't we try that? V result.
This looks like the right syntax.
Worked.
Okay.
Oh, no.
It worked. You sort of just moved your problem here. We somehow need to figure out, this is the normal way of doing a cast.
What is?
This parentheses syntax.
Oh, okay. But it needs to be some sort of a checked.
Yeah, so what is a checked cast?
Cast Java. Perform a checked cast. Is instance.
Okay, we can do that.
Class cast, what? Oh.
Okay, so let's try this. So we want to say object value equals the thing in the bucket. We say.
What if you just do v.cast? That might do it. Nope. Oh, sorry, I hit delete.
Okay. I'm trying this. Oh, it's bad. Perform instance of check against type parameter v. use its erasure object instead, since further generic type information will be erased at runtime. Okay. There must be a way of casting back to a erased type. Java cast to type parameter. Casting object to generic type. Thank you, Stack Overflow. Oh, you just have to try and catch it. Okay, we'll try and catch it.
Okay.
Oh no, wait, that's the part of the question. Okay.
I see. You're reading the same thing I am.
Okay.
What is this class thing? That's just there.
I don't know.
Why?
So maybe we'll just try to catch the class cast exception. So let's just try this. Try to return, say, v and catch the class cast exception. Okay. So mad. Okay.
So I'm sorry. Explain to me. Java, they erase the types. Generic types are erased at runtime. So it's like if Dart used to do this. No, maybe Dart didn't do it. It's like if you use list in Dart without the list T, it's like a generic list.
Sorry, William, what is the only way to remove the warning?
Checked exceptions are effect types. I don't know.
Yeah. So okay, so let's talk about how this works in other languages. So let's think about in C++ when you have a generic generic in C++, you take a type parameter, and when you instantiate that generic, let's say with a given type, like let's say the value type was animal, right? What the C++ compiler do? Catch the exception. Okay. So we just need to find the actual name of the exception. So what the compiler will do is it'll just literally copy and paste a copy of that template class and fill in your type. And so if you instantiate it with animal, and then you instantiate it with circle, and then you instantiate it with airplane, you'll end up with 3 copies of it. And so Java was very sad about that. They didn't want to have so much binary bloat because they imagined their code being transferred over the network. They said, aha, instead of doing that, we'll just erase the type. So anywhere that you wrote a type parameter, we'll secretly translate that into object at runtime. And because objects are object is the root of the Java class hierarchy, anything that you do with any object can be done with object. But then the types are still useful to do type checking. Although now we're trying to figure out how to actually get the how to get back from our erased type to the real type.
I just want to see someone else do this. Someone must do this. Public mystack class e class.
What is class E class?
Maybe you're just supposed to pass the class.
You should have access to the source hash map in your editor. I see. You want to see how they do it? Isn't that cheating? William is suggesting we go look at the standard library hash table to see how it does it.
Well, I was just looking for any other generic. I don't care whether it's HashTable.
Mm-hmm.
I just in function static. Oh, what's this suppress warning unchecked?
Oh, okay.
That sounds useful.
Yeah.
Bam. Goodbye, Java.
Solved it. Nailed it.
The internet told me how.
This is the problem with these kind of things. Is okay, just we solved it.
Well, I don't know what in C++, you have to use the right flavor of cast. Is it a dynamic cast? Is it a reinterpret cast? Is it a static cast? Is it a C-style cast?
Java array typing is unrelated. It's special. Oh, great. Is it covariant? All right.
Okay,
This is a whole argument in the history of Java where there was a hole in the Java type system because the array type was a little bit too permissive, and so somebody figured out how to like trick the JVM and
to be clear,
hack
Java
the
is
thing.
25, 30 years old. Like what?
Yeah, it's like
30 years old.
the grand ancestor of everything that we do today. So,
Yeah, so
they
like
didn't know. They're like incredibly forward looking. They got so far, and they made some mistakes. Like I think the most famous mistake is the equality operator on the string object. Like equals equals on string doesn't actually compare the strings. It compares the object identity of the strings, which just trips up everyone learning the language, and especially people like me who only use it occasionally.
I have no idea how to like. Is var a Java thing?
No, you got to like write the type. I mean, maybe in modern Java you don't have to, but in the Java that I know, you have to actually write all the types. You're gonna do from int to what? To int?
It seemed to take var. This is Java 11, man.
Okay, maybe they've come to the future and they accept.
They might have come to the future. Is it like .new or like? I bet I got a new.
You got a new.
Yeah.
And you can't do this because these are so in Java values are different. They don't derive from object, so you have to do integer, which is the boxed version of integer. This is another thing that later languages did away with. They
let's just try 10.
Okay.
So
how big is our hash table? Our hash table has a capacity of 10, by the way. So this is very likely to explode.
Well, it's not going to explode. It's just going to overwrite.
Okay.
And then what I want to do after I do that, I then want to get them again, and I want to.
You want to like print out like, oh, one now is okay.
And it'll just prove that we printed up.
This is another thing about Java. It's like system.out.println. It's like how much is like print? It's gonna be okay. Like Java was like super worried about like name collisions, so they definitely did not want to put print anywhere near the global namespace.
Yeah. Okay. Type expressions must be array type, but resolve to HTable integer.
Right. You have to say insert. Like it's no.
Because we haven't done operator or whatever.
Yeah.
We haven't done operator overloading, which presumably is a thing in Java.
I don't know. It wasn't in the distant past, but the past is the past. But Java, to its credit, does have auto boxing. So notice that we have the value type integer, and we pass it to a thing that took capital I integer, I mean a box integer, and it auto boxed it for us. So they did do auto boxing. Like otherwise, your code gets crazy verbose.
Get?
I think lookup is what we called it.
I don't know how do they do interpolation like this, or is it how did Java do that?
I don't know. We're gonna find out. Java is integer. How to print an integer? Okay. Plus. The plus operator will do it for you.
Plus format. There's a format function. Okay.
We'll just use the plus operator.
Yeah, plus works just fine. Okay, perfect. All right. Right. Well, it worked.
It worked. Suspicious.
Yeah, something.
What is? Can you print out the hash code of each number? I bet the hash code, like I bet integer's hash code is just itself.
It's just itself.
So it perfectly tiles.
Oh, well, that's fine. It's very easy for us to prove that it doesn't if we just do 20, right?
Yeah.
No. Oh, yeah. Okay. Yeah.
This is a good example of why. So, like, as an example of why you want to use more elaborate hash functions, because if integer's hash code is just itself, then if your program is dealing with like user inputted integers or integers that come from somewhere, they're very unlikely to be randomly distributed. Whereas a hash function really wants a hash table really wants its hash values to be randomly distributed.
Yeah. Well, I mean, to be clear, all mod does. So, like, if you mod by 4, all you're doing is you're taking the lowest 2 bits in this thing. So you're discarding. Say your hash function produced a 64-bit integer. You're discarding 62 bits of data, and so you better is you better hope that the randomness of your hash function was evenly distributed across all bits, including those last two. I really only care that it was distributed among those last two. Which clearly it is not for, I mean, we could print out the hash table. You said you wanted to see what i.hash code. I think we're going to find that i.hash code is exactly I.
Yeah, I'm just looking to see if there's like a convenient hash function in Java.
Oh, the primitive type of int? There must be a way to like...
You capital I integer. Yeah.
I have to new it? Well, great. Tell me what it's supposed to be. You took away my integer one. What am I supposed to do?
You have to call hash code is a function. You have to call it.
Oh.
Yeah. Prototype integer. Yeah, just say new integer.
I didn't like it.
No. And deprecated. The constructor is deprecated. It's fine. You can still use it. Maybe there's a fancier way of doing it.
Whatever. Did it work? The deprecated constructor?
Yep.
All right, great. So we proved that it is in fact just the number itself, which is not a very useful hash code. I mean, it's useful in the sense of that the property they're probably trying to go for with hash code is that hash code and equals should, if it is equal, it needs to, or sorry, if it is not equal, the hash codes need to be different.
Printing on the object is a capability thing. Fine. This is true. Let's hope the hash function is not naturally aligned object pointer.
That would also be a problem with our current implementation because we'd just be chopping off all the interesting bits and we'd only be hitting the 0th bucket.
Yes. So do you want to do collisions or do you want to do a fancier hash function?
No, let's do collisions. I think collisions. So the easy way that I can think to do collisions is just we check the value, and then we put it in we turn our buckets into, again, I don't know what the proper.
So you're going to do chaining.
Sure.
So basically, when you have a collision, you're just going to make a little linked list.
Yep. Yeah, either a linked list or an array, but yeah.
Mm-hmm. Great. Okay, so that sounds good. So this is going to get a little more complicated, right? So this is like the.
So first we have to get the bucket. Yeah.
Right.
Mm-hmm.
Okay. So this is like the chain, right? This is the object. Just what Copilot wrote. Our chain is going to be, we look up this thing. Okay. If the chain is null, meaning there's nothing here, then we we make a new object.
We check to see if the chain contains the value.
So do you want the chain to actually be a linked list? Here you made the chain an array, which means we'll have to reallocate it a bunch. That's fine.
It depends on, like, does Java have a vector or whatever that will self reallocate for me?
Yes, it has an array. What do they call it? Array list?
Yeah, that's what I want.
Array list, yeah. Okay, so we'll make it an
array
array
list. I can
list.
use a linked list, but this linked list, typically you have to modify the type that you're turning into a.
So then you want to do this, basically. New array list.
Oh, interesting. So it's an array of array lists?
That's an array of an array list.
Whoa.
It's not happy about that?
Type reads really weird.
I could have done it wrong. Is this not right? It's got a red squiggle, so maybe I didn't do it right.
Can I create a generic array of array list object?
Why not? Why not? Do you want an array list of array lists?
Sure. I mean, like, we're not going for speed here. We really are not going for speed. So sure. Let's do array list of array lists of object.
Okay.
That's like a vector of vectors of objects.
Yeah.
We don't actually give it a capacity, right? Oh, I see. We do, but it's
still mad.
Can it convert from array list object to array list object?
Oh, too many brackets.
Oh.
Okay.
Stop brackets. Okay.
What is this? Get length? How do you get the length of an array list? We'll find out. How hard could it be? Does Java still not have like
array list size?
Properties? Size. Okay.
Expression must be a type. Oh, okay, yeah. All right, so buckets index. This is going to be an array list of object.
Yep. And this is going to be .get.
Okay.
And then can this be null? I guess it would be null. Well, now we need to say buckets.set, right?
Yep.
At index. Okay.
Mm-hmm.
You stop typing. You need to type the rest of this stuff. Okay.
Hold on. What do you get index? Oh yeah. Yep.
Right. And then we need to say chain.
Whoa.
We say chain equals this, and
Yep.
then set the chain. Right. And then I'm hoping array list has like chain dot add.
Yep. But we also need to check to see if it's already there.
Oh, okay.
So we need to do if chain dot contains value return.
Yep.
Like maybe
throw,
add or
right?
do that.
It's throw, right? Like throw exception key.
Ooh, is it? Like I don't think so.
Oh, you just want to. We should replace, right?
Yeah, you want to replace.
We want to replace. So we need actually the index. So contains is not going to give us everything we need.
Oh, so actually we need to keep both the key. Hold on. If you're replacing a value, how are we going to do that?
So we lost track of what key the value had. So sorry, just to complete your thought for the audience, like
Yep.
You've got two different keys storing the same value.
Yeah. So we need to keep the key and the value, and that's what Copilot was doing.
Correct. So let's make a little inner class, which is like the entry, which is the key and the value. Okay.
Thank you, Copilot.
So then our entry.
So this is now entries.
Yeah.
But Java cares about order, I presume.
I have no idea. And Java inner classes are super weird, by the way. If we make a digression about inner classes, an inner class will have a pointer to its enclosing class for a reason that no other language can understand, but it does.
Well, again, it's like you have to give Java credit. This was 30 years ago. And
Yes.
so much of the learnings of the last 30 years, I'm sure, came through like folks like Java figuring out what we were not supposed to do.
Yes.
Because that's a lot of life, is figuring out what you're not supposed to do.
So it normally doesn't matter because normally you don't care or use it. But as William was alluding to, some people try to use Java as a capability system. And then there's this magical link between objects that if you don't know it exists, will mess up your capability system. Okay, so we're making progress. So so I think we can override equals, right? Public bool equals. Well, I guess we just need to. This is not really correct, right? We need to like iterate through this chain to find if there's already an entry for this key.
Correct.
Okay, so we should say for.
Yep.
Yep. Then overwrite the value. So I guess the value isn't final, but the key is final.
Does Java have else?
No, Java does not have for else.
Some language I learned at one point had for else, but it's not actually what we want.
But it's okay. But here it returns anyway, right?
Yeah. So we just
so we make a new entry and we add it to the chain.
Yep.
Chain add new entry. Yep. Okay. So now let's look at delete. Delete is the same thing. We need to get the chain. If the chain is null, then obviously the key wasn't found. Nothing exciting happening. Now we need to iterate through the chain. If we find the key, and we need to remove the key from the thing. So, so we'll find out. This will be sort of interesting. Remove entry. So this is normally a dangerous pattern here, right? Because we're iterating a thing and mutating it.
It may even throw.
It may even throw. We'll find out when we write our tests. Otherwise, if this doesn't happen, then we couldn't find the key.
Because some languages will mark the object while you're iterating it. Like in this, they'll like mark it as it's being interval so that they can throw.
Let's prevent us from modifying the list during iteration. Okay.
I mean, we could do this other ways too. Like,
we could, but I'm just curious to learn. I think we should, like, if this is
like,
a problem,
we could also just have an entry, set it to null, see if we find it. It's like we could do first where, right? I presume that chain has a first where or.
Let's see. The last index of remove if. It has remove if.
Yeah, remove
is the way of doing it.
That'll give us a bool.
Right, that's fine.
Yeah, fine. So if, remove if, or it'd be like, we just do like if not remove if, or whatever. We can do if remove if, and then we return.
Yep.
And then the if here, I don't know, what do Java lambdas look like?
They're totally crazy.
Because I got to do like new predicate.
No. That was old school. They now have. Sorry, if you don't resume the iteration after removal, it's okay. Okay, that's good to know.
Okay.
Well, let's do it that way then. If that's going to work, they have new fancy syntax for writing callbacks. It used to be you like had to new up an object that would receive the callback, but they've become more sane over time and allow you to write syntax that's a little bit more compact. And then we do look up the same thing, or similar at least. Thing. Return value for the exception. Now I think we can remove our suppressed warning.
What?
Yeah. There's another reason that, anyway, yes.
Okay. We test it?
Yeah. Will even showed us the magic syntax. Yes. Which is sort of a same callback syntax.
Main, divide by 0.
Divide by 0? Where are we dividing at all?
This bucket size, it's empty.
Oh, why is it empty?
That's probably capacity, not. There's nothing in it. Maybe size is so you want.
We need to actually allocate. We probably need to actually allocate it. I don't know if we want to go this far. This seems a little far, but there's got to be like a fill with null. So I think what's happening is the constructor is just hinting how much. Yeah, it's the initial capacity. Constructs an empty list with a specified initial capacity. So now we want to actually like populate it with nulls. Add all.
There's an ensure capacity.
Contain ensure.
Fill array list.
It increases the capacity, but doesn't actually put anything in it. Index of.
Looks like there's a fill.
What is the fill called?
Oh, collections fill? Whoa.
Is it a collection?
It's a Java util thing.
I don't actually see an efficient fill. We can just call add null a bunch of times.
Yeah, whatever. That's fine. Yeah, this looks great.
Well, I don't want to pre-allocate all these things. That's going to be expensive.
Why?
Because many buckets may never ever have a thing in them. So this
Oh.
lazy allocates it. So just fill it up with nulls.
Okay.
Okay.
Okay. I think there's also a buckets.ensure capacity. Yeah.
Yep. But that's just going to set the capacity, not the size.
Yeah. Well, that's what this constructor thing did too.
Mm-hmm.
Add all. Yeah. Okay.
We can write a to-do. Like to-do, is there a more efficient way of doing this?
Oh, buckets.size. Yep. Okay. Let's try it. Oh my goodness. We put them in and we took them out.
The future is now. So now what's the problem? What's the biggest problem with our data structure?
I don't know. It works.
Well, I think the biggest problem is, let's say we dumped in a large number of things.
Mm-hmm.
Our table is only ever going to be 10 big. And so if we dump in 1,000 things, when we do a lookup, we'll have to like walk this chain. The chains will end up being like 100 things wide.
But we have a problem of that we would have to rehash everything if we moved it over to a different. If we resize, we have to rehash everything.
Yeah, so I think we should try running a very dumb resize that is expensive because it'll rehash everything. Hokey pokey achieved. Exactly. We put the integer in. We don't get a copyright strike. I don't know if you get a copyright strike for singing poorly.
I have no idea.
But I think we should write a basic resize. So we should keep track of the load factor, and then if the load factor gets too big, we'll resize. Yeah. So the load factor basically says hash tables perform pretty well up to some percentage. Like if you put too many things in, the likelihood that you get collisions goes up. It starts going up quite dramatically. And so you want to keep a load factor of like, let's say less than 75%.
Well, I mean, that's another thing we could do is that we could write like, how do you get diagnostics on your hash function? Because you need that. If you're actually implementing a hash function, you want to get diagnostics of it on your hash function.
That's true.
But like, what's your collision rate and
so you want to write some of that? So let's say like
I don't know. We don't normally reach. I mean, we're at 50 minutes, so like we could also just talk about pizza for a little bit. And
okay, well, why don't we write down our to-do so we remember what we want to do? So we want to do keep track of the load factor and increase the number of buckets when the load factor exceeds a threshold. Thank you, Copilot. We want to keep statistics.
I've been writing a whole bunch of code last 2 weeks. By the way, I do not know how we wrote code before Copilot.
Can I use this in production? You can. should you use it in production? You should use it in production as much as you use the malloc implementation from the last playlist. No, which is to say, for Echo or programs that don't call malloc, great.
This is better than malloc because this doesn't crash, and although it has terrible pathological performance, it actually functions as a hash table.
Right, it's on the path to actually become like if you go and iteratively solve all these problems that we're encountering, you will actually end up with a good hash table.
Like, yeah, you could do some. If we just added resize and some sort of threshold aim, you'd be fine.
You'd be algorithmically fine. Like there's a lot of tricks that people pull to make to do well on constant factors. And for many cases, that doesn't matter. But if you're actually doing a hash function that's in a standard library that a million people are going to use, then you want to play all the tricks to get all the constant factors.
Well, I mean, that's the real reason why you wouldn't use it in production. It's just that there are so many better implementations than this one. But the interesting thing for this is that, so again, I mentor various folks on the side, and it just, if you've never implemented a hash table, which we did in 85 lines of code, it's absolute magic. And I think that's just generally true of science and computing, is that it's not magic when you look at it, but it's 1,000 layers of not magic. And it's really hard to see through the 1,000 layers. You have to just like look at each one.
And part of it is like I understand many layers of the software stack that we all work with, but I don't understand it in complete detail. But as you see, like I kind of knew the basics of the hash table, and so could go through and work it out. And like that's really the important piece, is to be able to dig into whatever layer is important at the moment and like figure it out. Like some combination of Google searching and looking at the actual source code of the standard library and be like, okay, this is, now I understand what it's doing. Because sometimes it matters. Like,
I actually think the Google searching is hugely important, and I think we do that a lot in this. I just think about this doesn't have to be Google, but my entire professional career has been searching Google. Like Google came to be right as I was in college, leaving college, and so much is just going and finding things on the internet and learning them.
Yeah, somehow someone manages to merge together Copilot and Google into one like programmer assistant. They'll have the ultimate programmer assistant.
Yeah. The thing I really like about Copilot is that it does sort of mini code generation for you. So commonly find myself looking at what it splats out for the various cases, and then I will go edit something and then have it re-splat out. But I will delete the thing that it splatted out and I'll have it splat it back out again. And it's like I'm using this little code generator for things that aren't worth writing a code generator to go, generate some separate file for, but it's really convenient to have it like splat out the 5 cases for you.
I also find it's helpful to just unblock, because like when you're staring at a blank piece of paper or a blank function, like how do I get started? And if someone just gives you a bunch of wrong code, you're like, that code's wrong. Ha 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 ha. It's like, so it's wrong here and here and here. And pretty soon you're writing the code. Like,
it also changes the job. It's all about reading code, which I think in many ways is the job. Anyways, as you saw, like the reason, I can go back and share the screen, but like the reason why I write these comments is just because of 20 or 30 years of doing this job. I just know that the next time I look at this, I won't remember why.
But these comments are really hints about refactoring. Like really each of these things should be refactored into a function that does what the comment says, because then it's easier to chunk a 3-line function that calls 3 functions than, but it's the stages, right? Like the next stage is, I mean, we've done this on the show 100 and whatever it is, 22 times. Like, it's just the same process over and over again. You can use it to climb any hill you want.
Oh, we had some thoughts. I was going to ask you for thoughts. You had me pull up some images.
Now I'm terrified. Oh, the Easy Bake Oven.
That our viewers might not know what an Easy Bake Oven is.
Because we're from 1992, and that was a long time ago, turns out.
The place that we cook the code so the Easy Bake Oven was a thing that came out when I was a much younger lad. And it's a plastic box with an incandescent bulb in it. It turns out that we used to fill our houses with these heaters that emitted a small amount of light called incandescent bulbs.
Wait, you would actually cook the food with an incandescent bulb?
That literally has an incandescent bulb in it that you cook the food with. And supposedly this thing could get up
amazing
350 degrees Fahrenheit.
With an incandescent bulb? No way.
An incandescent bulb. Have you ever touched one of those things? They are.
No, I just saw them on TV. It was just like
a. I mean, the thing that used to be in your ceiling, right? Like that'll crisp your fingers right good.
I guess it's so good it can cook a cookie.
It also will cook a cookie. I found out there's a modern one of these too, which
I know is an LED light bulb and does not heat the food at all.
I have no idea. It's probably not an incandescent bulb. It's probably like a a heating coil, like your toaster has. But anyways,
That's amazing.
So
in a future episode, we will explain what StarCraft is and what Vespian gas is and why it's important.
I think that the StarCraft is still a part of the zeitgeist, is it not?
Well, that's because they came out with StarCraft 2 and they rejuvenated that thing only 10 or 20 years ago.
Java is scary log for shell like this. You mean like an easy bake oven? Yes.
Oh no, I think what Kali is referring to is there was a vulnerability recently called log4j.
Yeah.
Very, very, very common logging library that had a vulnerability. It's not Java's fault. It was somebody wrote a logging library that.
Well, it's just the general supply chain, problem that we talk a lot about, but have not even begun to solve, really, as an industry. Because modern open source is just you depend on 300 packages, and the question is, where the heck did those 300 packages come from? And my goodness, class loading is weird.
All right, I can go on a rant about class loading if you want. So the reason class loading is weird is because it is the foundation of Java's security model. And so the original idea is that you'd be running a lot of mutually distrusting code inside a single JVM. Okay. And the way they would remain separate from each other is they would be loaded by different class loaders. As the class loaders create the what in Dart we think of as an isolate, or like basically the unit of security isolation. Mm-hmm. But then the JVM itself has a bunch of sort of trusted Java code that it runs that needs to actually interact with all the other code. And so you end up, it has its own internal class loader that then somehow secretly injects itself into everyone else's namespace. Anyway, that's why it's complicated.
Seemingly unpopular opinion. Object-oriented programming is good. Oh, I read a lot of object-oriented programming.
Well, I think what this person is referring to is there's a trend right now where a lot of the newer, cooler languages don't have object orientation, whereas Java is like super object oriented, right? Mm-hmm. But I think it's just different tools for different jobs. Like for writing a UI toolkit, like object orientation is.
Well, that was just another thing we learned with Flutter was just how important that was, because we looked at I think we looked at Go and like other non-object oriented languages. Like, well, how do you do this? How do you write a render tree with this?
Yeah. That's true as possible. Guessable string names. What is guessable string names?
I don't know. Does Java have some security that's based on non-guessable string names?
No, but there's a funny security bug in early Java. Let's see. It's just going to ensure I found it. I see. Yes. When he's talking about when you serialize and deserialize, your class loader gets embedded in the files. Anyway, so there was a very amusing security bug in early Java where the string class wasn't final, which meant that as a malicious actor, you could subclass string and then pass your string object to like security monitors and various built-in functions that would assume your string behaved like a string, and you could just lie to them and just be like, okay, I totally equal anything, therefore I equal whatever your password was, therefore log me in. Mm-hmm.
I feel like that was around the time that I was using Java, that kind of thing.
Yeah, nowadays people don't really run mutually distrusting code inside the same JVM. That's not a very common thing that people do. It's very difficult. But.
Well, there again, just get back to like what is it that helped Java, or what were the things that Java did that actually made it successful? And my guess is that architecture independence, and you did not need a PhD in malloc to write in it, where it's like that, and it probably had a really good ORM, really great database bindings. Those are probably like I'm just shooting from the hip, hot take, whatever. But
yeah, I think it also got picked up by a bunch of big companies who built like server infrastructure out of Java. So then like you could plug your Java code into their big Java system, and you'd have a big working server that did something useful.
But there were like architecture wars at this time, right? Like there was still PowerPC, and there was Itanium, and there was ARM. I don't think was a thing.
Yeah, marketing is also important. Yeah, that's true. And so like not having to worry about any of that, just saying, oh, here's my jar file.
Which C++ had to worry about all that, right? And I suspect that mattered when somebody wrote your server, and they had left the company 5 years ago, and you now could upgrade to Itanium and not care, or whatever. And we pick on Itanium, but another failed architecture. Yeah, what strikes me most about Java, and maybe it's just the marketing wasn't directed at me because it was all enterprise marketing, but the marketing that I saw from Java was all the parts of Java that failed. All the like applet stuff and the running on a ring stuff and running on your microwave and whatever, like all that just failed. But Java completely won in the server space. At least
they also were like super big on getting their logo and everything. Like I remember I had some flip phone at some point where it would run as normal software, but then if you wanted to run some game or something, it would like the little Java icon would pop up on the screen, and then it would take it like a few seconds to load, and then you could be playing this fun game. It was like super weird. Like why? Like I knew what the Java logo was because I was into computers, but like I can't imagine that most people had any conception of like why this coffee cup showed up while they were playing this game. It didn't make any sense.
Yeah. Anyways, any last words before we retreat for the week?
So next week is Thanksgiving. Is Thursday. So we might do the show on a non-Thursday day, but we will keep you posted on Twitter, assuming Twitter continues to exist next week.
It is true. I don't know how we will communicate with the peoples of the ducks.
Those of you watching in the distant future, this is the week when all of the employees of Twitter stopped being employed by Twitter, and we had no idea what was going to happen next.
Correct. We don't.
So
Twitter was great this week. Like really, there were some tweets going by today. It was like, "End of Twitter. Twitter is best Twitter," or something like. And yes, totally. It's amazing. Anyways,
don't spoil it. Don't tell us how it turns out. We're going to find out the hard way. Anyways, see you next week.
Have a wonderful week, all. Take care.